Hi, everyone. I'm Marcelo. Thanks for the introduction, Rishi. And this is, I'm going to present this talk that is getting your custom AI inferencing pipeline started with Vector's AI Deployment Bootcamp reference implementation. So let's get into it. We're going to first go through some introductions of myself, Vector, and what bootcamps are in general regarding to Vector. I'm going to talk a little bit about inferencing pipelines, the different types, and some things that you have to watch for. We're going to then jump into some important concepts that you have to pay attention to when you're doing inferencing pipelines. Then we're going to jump into the code for the reference implementation. Just going to go quickly through it and explain the basics of it. A quick conclusion, and then we're going to open for questions. So for the introductions, I am Marcelo Lotif. I'm senior software developer at the Vector Institute. I am a master in applied informatics, obtained in 2012. I have 17 years of experience as a software developer, 8 of those years as a machine learning engineer. I worked at both startups and big companies like Apple, where I developed some federated learning pipelines. And I have been developing and managing training and inferencing pipelines for computer vision, NLP, and federated learning. The Vector Institute is a company that I work for since 2023. It's an independent, not-for-profit corporation dedicated to AI research, and is a member of the Pan-Canadian Artificial Intelligence Strategy, together with Mila in Montreal and with Ami in Alberta. It was established by Jeff Hinton, Brendan Fry, and Raquel Rutasun in 2017. And one of the goals of the Institute is to support AI adoption in Canadian industries. And one of the ways that the Vector Institute does that is through bootcamps. So we run various types of bootcamps with our industry partners. And for those bootcamps, we produce what we call reference implementations, which are mostly GitHub repos that the participants use to develop their bootcamp throughout the hands-on stage of the bootcamp. Most of those reference implementations are open source, and they're available on our GitHub. So you can visit github.com/Vector Institute and browse through that. There are the reference implementations there, and there are other open source projects that we make available on the GitHub as well. So I welcome you to take a look at the project that we have and see if there's anything you can benefit from. This bootcamp in specific, that the reference implementation that I'm going to present here was called AI Deployment Bootcamp and was run in October 2024. We had 19 teams from 14 different organizations and 89 participants in total, all from Vector industry partners. The goal of the bootcamp was to go over the fundamentals of inferencing pipeline and how to set it up. So like I mentioned, we developed this reference implementation that you can use as a starting point for your own exercises during the bootcamp, right? And that is available here at the GitHub, Vector Institute's GitHub AI-Deployment-Bootcamp. That's what we are going to go over soon. But before we do that, let's go over some fundamentals about inferencing pipelines. So what are inferencing pipelines? So once a model is trained, you need to serve that model predictions in a production environment, right? Because of the goal of the production environment is different than the training environment. The way that you should set up the pipeline is different, fundamentally different from the training pipelines. But before you jump in and you start to develop your pipeline, you have to ask a few questions to make sure that the design decisions that you're going to make are going to be the correct ones. The first one I would say, one of the most consequential is if the predictions need to be, how do the predictions need to be served? If it is the two main types that exist, it's online and offline. Online is a synchronous kind of serving, where the user requests the prediction and it's actively waiting for a response, while the offline is the opposite. They make the request and the response can come afterwards. So that can make a big difference on the way that you architect your pipeline. What are the latency requirements, or how long is the user going to be willing to wait for? How long is it acceptable for the user to wait for a response from the pipeline? What are the hardware requirements of the model? So that's going to impact the cost of your pipeline. That's going to impact scalability. So those are questions that you need to ask. How will success be measured? That's a really important one, to make sure that your model is working as expected, both working as you expect it to work while you train the model, and also if after you put it in production, when it is exposed to production data and to the pressures of the production environment, if the model continues to perform over time the way that you expect. It's something that we're going to talk a little more later, that it relates a lot with monitoring of your model. And it's a really important thing that you have to do, is just to define what are the metrics that you're going to tell, that you can monitor, that's going to tell if your model is performing successfully or not. How often is the model expected to be retrained and redeployed? That's for some pipelines, that's a more important question than from others. There are some models that you expected to train once and keep it running. Some others, they have a more strict regime of retraining, let's say monthly or weekly or daily even. And that will also affect some decisions that you make when you're making your inferencing pipeline. Is it better to develop a pipeline on premises, on the cloud, or is it hybrid? Depending on the organization that you work for, you can have some data restrictions or some compliance restrictions or auditing that require you to have a certain kind of infrastructure on premises or on the cloud. And then you have to ask what are the advantages of keeping in one or keeping in another, or even keeping in both. That's the hybrid part here. And if you decide to do that, you have to make sure that the communication between the premises part and the cloud part is effective. Some more differences between training pipelines and inferencing pipelines. On training pipelines, the pipeline on training is often prototype and experimentation oriented, or sometimes it's more robust for training purposes. Sometimes training is more computationally intensive than making an inference. So the way that you make a pipeline is different because of that. The data pipeline can be different as well for training. And the way that you distribute the architecture, especially for larger models, on training pipelines is different than on inferencing pipelines. While on inferencing pipelines, you have to pay attention to other things, like you have to have robust testing to make sure that that the pipeline is working correctly, and also afterwards, if there's fixes introduced, if the fixes actually fix the problems that you are trying to fix, if they don't have other adverse consequences and things like that. It is most of the times optimized for lower latency. So the fastest the response from the model, the better. So that's what you have to watch for on inference pipelines. You have to have a focus on scalability of your pipeline, in a sense that on production environment, that the data flow fluctuates depending on the nature of your business. It can fluctuate daily or weekly or monthly, and your pipeline has to be able to adapt to that. And also reproducibility is pretty important, in the sense that you have to be able to bring up multiple copies of your pipeline if you want to do some testing or some QA. and you have to make sure that the pipeline is reproducible. Also, model monitoring, like I mentioned before, is super important, that you have to pay attention to that on inferencing pipelines as well. So just going quickly through the types, I mentioned online and offline. There's also a third type, streaming. Those are the main types. Of course, there are some variations between them, but those are main types that you should pay attention to. Like I mentioned before, real time is synchronous, so the response time matters, and you have to optimize really for low latency, because the fastest you return the prediction, the better. While batch is offline, which means that is synchronous, it can be triggered off peak to avoid unnecessary pressures on let's say production databases and such. And you have to optimize for high volume in this case. So it changes a little bit the focus of the pipeline. So the way that you develop that can change a little bit as well. While streaming, you're thinking about a constant stream of data coming. So you think about devices of like Internet of Things or sensor data. Then your pipeline has to produce predictions on the same rate that the stream is requesting. So that's a few different pressures that you have, but it's similar to online, but it's slightly different. Some more important concepts here that some of them we have adopted in the reference implementation that I'm going to present. But one big thing that I like to stress is infrastructure as code. Is pretty important, and that's the reference implementation was made with that in mind from start. It's really important for reproducibility, like I mentioned before. If you want to spin up the same pipeline on different environments, like staging environment or a dev environment or QA environment, and you have to make sure that those pipelines are as close as possible to the production environment. So when you make tests on them, they are also you can say they are extensible to the production because they are as close as possible to production. So reproducibility is key on when you're talking about infrastructure as code. And because it is code, it is also easier to code review, and there are all the benefits from code reviews that we know as the software developers. Also versioning and tools like Terraform, which is the one that we use on the reference implementation, is easier to roll back as well, if you make some changes that you don't need to be there anymore. And there are some tools that you can use. So Terraform, like I mentioned, there's Ansible, which is a slightly older tool, but still use. And so there are some provider tools as well, depending on the cloud provider that you use. You can have CloudFormation from AWS, Azure Resource Manager from Azure, and Google Cloud Deployment Manager from GCP. You can use those if they are more convenient for you. You have some auxiliary tools that you're going to need as well. Git for version control and code reviews. Python scripts, because unfortunately Terraform is like a kind of a new technology, not exactly new, but not all the APIs that exist on Python and Bash tools, they exist in Terraform the same way. So you end up using some Python scripts and some Bash scripts to manage pipelines as well. Some more important concepts, scalability, like I mentioned before. You have to, when you design your pipeline, you have to think about what are the points of the pipeline that are going to have the most pressure and bottlenecks. So you have to start thinking from the get-go if the model is going to be the big a bottleneck here, or if the data and the feature store is going to be the bottleneck here. So you have to design your pipeline with some scalability in mind on places that you foresee that's going to be an issue. Also, after scalability can also be done afterwards, which is it might be a little harder to add after the fact, but definitely possible. And the need can arise when you do stress testing and some other testing, and there are obviously some unforeseen pressures that can arise after you do those tests. Monitoring is also super important, like I mentioned before, to make sure that the model that you are deploying in production perform the same as the one that you did during training. And also, if over time the model keeps the same level of performance, or if there is any degradation. There are some other things that you need to be worried about, like data drift, prediction drift, and concept drift. And those things can only be detected if monitoring is in place. So it's pretty important to have that. And I like to share this image when I talk about monitoring, because if you are used to develop regular APIs like me, uptime is one of the most important things, and make sure that is correct and tested. But when you start developing AI pipelines, you have to worry about a lot of other things that are under the surface here that you don't have to worry about when you're developing regular pipelines. So that's one of the main reasons why monitoring is so important. Some more advanced concepts here that you may or may not need, depending on how complex your models and your pipeline is. You're probably gonna have to think a little bit about feature versioning or data versioning and model versioning, especially if you retrain a model constantly. You need data versioning to make sure that the data that you're feeding the model is the data that the model expects it to be, especially when you retrain the model and the data expect to be different. So you have to make sure that you feed the right data to the right model. Oops, sorry. And like I mentioned, it's especially important if your data changes very frequently, or if your model is retrained very frequently. So you're gonna need to start thinking about that. There's one thing on cloud providers, there's very basic support for both of those things. On the reference implementation, for instance, there is very basic tools for both data versioning and model versioning. But if you need something more advanced, if your pipeline has to be retrained, let's say weekly or daily, let's say, you're probably going to need some external tools that I'm going to talk a little bit about in a few minutes. Also, this is also a more advanced concept of continuous integration, continuous deployment, that it's also needed if you retrain your model more frequently. Then you have to start thinking about automating the delivery of the model with continuous integration and continuous deployment. And even further than that, you have to think about automating the training of the model as well. So you need to have continuous monitoring to tell you when the model needs to be retrained, and continuous training to kick off a training of the model. And the continuous monitoring is going to be important afterwards when the model is deployed again, to make sure that this version of the model that's just trained has a good performance as well. So this is for more advanced pipelines. Cloud providers are not going to help you a lot on this. So there are lots of other tools that can help you in that. And I listed some of them here. That's not all. Some of them are open source that you can develop and deploy yourself, or some of them are paid tools that you can use as a service. They help with both the data versioning and model versioning part, and the delivery and training pipelines as well. So if you have those kinds of needs, you probably need to go into those third-party. That part is not covered by the reference implementation. Just something that I wanted to make sure that this is touched on the presentation. So with that in mind, let's go into the reference implementation really quick and go through the basics and explain to you how it works. So here, so when you land on reference implementation here on Vector Institute /AI-Deployment-Bootcamp, on the README file, you're going to see a description. What is this this one about? What it has been developed for? Some basic information about the structure, and we have two different kinds of implementation here that you can pick depending on which one you use. We have GCP and we have AWS as well. I'm going to go through GCP because that's the one that I'm most familiar with. So you can just click on here and you're going to go to the GCP README file. That's going to explain to you what you're going to need to set up. This is all you're going to have to do on your local machine. let's say, init with the credentials for the cloud provider, and go through some of installing requirements and things like that. And then you're gonna be met with those two different types of model deployment here. So I try to give some options depending on the type of pipeline that you're gonna need to deploy. One of them is for model from a local machine. Let's say you train a model locally and you want to push that model into a repository on GCP, and you're going to start a pipeline from there. So this is an example of how to do that. So you can click on this and go through the guide to explain to you how to do that. So here I'm doing it with a BART base model, but this is extensible to whatever kind of model you have. I would recommend, if you have that, you start up the pipeline as is, and then you modify afterwards. Let's say you push this model out, and then you change for your own. That's what I would recommend. Also, the other type is if you have a model in what GCP calls model garden, which is a repository of models. In this case, I have an example with Llama 3.1, but they have several models there that you can use, and then you can use this as a starting point, and then change with another model that you want to use, let's say Gemini or some other model. There's also a third one that I didn't cover here, which is if you're calling APIs, let's say from OpenAI or Cohere or some other provider, and that part is not gonna apply to you. But I would say you should just like run this pipeline as is, and then modify afterwards, because it's easy enough just like to bring it up and then modify as needed, and just cut the parts that you don't need afterwards. Also, two types, the online and offline. I have one guide for each one of them. So if you have an online pipeline, you can just go to this guide, and it has a diagram that explains how the pieces are expected to be once the pipeline is up and running. So like I mentioned, this is a synchronous pipeline, right? So the user is going to make a request. The ML API is going to pull the data from the feature store. It's going to send to the inference service that's going to return, and it's going to be post-processed and return back to the user. That's in a synchronous fashion. And this is how you run the pieces of it, and how you make a prediction, and what is the kind of output you expect from it. Similarly to the offline, so let's go to the offline here. The difference for the offline is, instead of making a request directly to the ML API, you put a request in a queue that the ML API is going to pull, run through, and then save the predictions into a database. And that's how you do similarly to the other one, right? So the AWS part is very similar to that as well. It's just that's on AWS, but it has the same online and offline with the diagrams to help you, and some more instructions that are specific to AWS. And of course, the diagram is slightly different because it's AWS data structures and components. So we just went through some basics of inferencing pipelines, explained some tools and techniques like infrastructure as code, feature stores, monitoring, and then went through the reference implementation that has some of those implemented for you, and some basics on how to start your own pipeline without having to do it all from scratch. Yeah, I hope that has been useful for you, and let me know if you have any questions.
Let me ask one question. You mentioned there may be a drift, like for example, data drift, predict drift. So how do you handle those drifts?
So yeah, so the first thing that you need monitoring to identify there's a drift happening, right? I would also there's a slightly different characteristics for each one of the different kinds of drift. But once you understand that and you have the right monitoring in place to identify that, you're going to see that your model performance is slowly going to degrade over time. And you have to have some thresholds in place saying that, okay, if it degrades less than certain level, or let's say accuracy goes lower than, I don't know, some number that you define for yourself, then you're gonna have to think about retraining the model with the most recent data that's gonna match the distribution or the prediction distribution that you have currently, as opposed to when you train the model the first time. So the key here is that monitoring is really important to identify that drift is happening. And then after that, it's you probably need to adjust something on the pipeline, either retrain the model or pre-processing to adjust the outputs to the changing landscape that you have.
There's a question from the audience. From your experience, what's a make or break decision that really needs attention?
I think it's a type of pipeline is really important that I try to stress that during the presentation as well. The online versus offline. It's a really big decision that you need to make from start. And also you really have to pay attention on how do you define that your model is successful or not. Like what are the both metrics that you need to watch for in terms of model performance itself, like accuracy or F1 scores or some other, depending on the model, that's going to be different, or some KPIs that you define that is on a business level, that is going to depend on your business. That's also important to measure to make sure that your pipeline and your model is being successful, right? So when you think about make or break, those are like big decisions that you have to make before you start developing your pipeline to make sure that that's not going to fail after.
There's another question: how Terraform is more useful than Python scripts? Is moving to Terraform worse?
For me, it is. Terraform is really good for both keeping a certain kind of like documentation of your pipeline, because the Terraform plan is going to have your whole pipeline there. Of course, you're going to still need diagrams and some additional documents, but you have the pipeline as this. It's on the script that is there. And Terraform is really good as well. When you change something in your pipeline, you can just run Terraform again, and Terraform is good. It's going to modify only the pieces of your pipeline that you're interested in and changing. So let's say you change the machine type on a VM, or you change some IP configurations or some VPC configurations. You can just run Terraform, and Terraform is going to pick up what is going to be changed, what's going to be removed, what's going to be added. And that is very good when you have to reproduce that on different environments. So let's say you have a development pipeline and you have a staging pipeline. It is really interesting that Terraform can do that, and then you can do that in one of the environments, and you can test and make sure it works, and then you can run the same modifications on a production pipeline, and the modifications are going to be done the same way as in the others. So it's important for reproducibility, right? And also rolling back is pretty easy. If the changes didn't work in the end, you can just roll back to the previous script and rerun Terraform. So, but when you say moving to Terraform is it worth, that is a big question as well. That is, let's say if you have a really good process in a company that's already working with Python scripts and it's not too painful, I would say probably not worth it to move, because everything is working, right? If it's if ain't broke, don't change it. But if there is some pain in terms of like it's hard to do the same changes, or the dev environment is too different from production because has been too many changes and someone forgot to make changes in dev. That happens all the time when you're doing it manually and through scripts. So if there is those kind of pains, I would say Terraform is going to help you with maintaining things uniform. It's going to be better for that than Python scripts for sure.
Yeah, there's another question from Vijin Palazzi. Yeah, hopefully this point is correct. Yeah. Maybe already covered, but what monitoring tools do you use within the CTCM pipeline for detecting things like drift?
So let's say thinking about GCP, which is the one that I have more experience with, it has already some tools internally, because drift is a very common problem to have. And GCP already has some monitoring tools for that, but it's pretty limited in a sense that it has a very basic tooling for setting up monitoring to detect drift. Right, but this is also something that you have to pay attention to see if the tools that the cloud provider that you use, be it Azure, AWS, or GCP, if they have the right tools that you need for drift. So I recommend you to get more how do you say, get more information about it in the sense of your model in specific, the model that you're using. What does drift looks like, because that's going to be different for language models, for computer vision models, and the metrics that you need to watch for are going to be slightly different. But once you know which ones are they, you can check with the cloud providers if they're going to support that. Sometimes they're gonna be able to support all the metrics that you want. Sometimes they won't, so you have to develop some stuff from scratch to monitor that. But it's important for each kind of model you understand how drift works, how to detect drift for each kind of model, and then you check what are the tools that you need to develop or use from the cloud providers in order to detect that.
Yes, thanks. Another question, is there any performance testing or stress testing strategy for inference pipelines, multiple iterations, multiple data sets, etc.?
That would depend a lot on your pipeline, how a pipeline ends up being. There is those tools that I showed at the end of the slides. They have those third-party tools. They have some tooling for stress testing as well, but most of the times it's not the whole pipeline. It's probably just the inferencing part of the pipeline. It doesn't cover probably the feature store. It won't probably cover the pre-processing, post-processing that well. But it will depend on the pipeline that you're developing. And will also depend online pipelines. The stress testing that you make is going to be slightly different than offline. But you have to watch for, let's say you stress your pipeline on, and you have to watch for the feature store. If the feature store is getting is holding back your pipeline and causing bottlenecks there, or if the model is causing bottlenecks there. So you have to try for a few different things, especially also if you have like an expensive preprocessing pipeline. You have to check if you stress the preprocessing pipeline, if that is going to cause bottleneck as well or not. So I would say for stress testing, I would say like it's never too much. Try to reproduce the same kind of load that you're going to have in production and the same kind of pressures, and that would depend on your pipeline. Sometimes it's the data that is going to have pressure. Sometimes it's the model that is going to add some pressure there. So you just go through like a few days of continuous testing and keep monitoring to see what are the slowdowns that you're going to probably see.
Yeah, let me ask one question. It may be a high level. In Canada there are two, actually maybe let me say this. There are 3 Turing laureates in deep learning. Jeff Hinton from Toronto, Yusuf Banya from Montreal, and Yang LeCun from New York, right? So they are working on deep learning, and they are say large language models, those things. And this year there are 2 people for Turing laureates in reinforcement learning. Lee Sutton from Alberta and Andy Bartle from University of Massachusetts. So I'm not quite sure it's very related, but maybe since deployment is also about collecting lots of experience, how the machine learning models are working. So there are lots of very good signals, feedbacks on say user experience, user feedbacks, those kind of things. I wonder if there may be something, whether you are working on, or maybe you try to collaborate with, for example, machine learning model trainers, right? So, building this kind of feedback loop. Any thoughts or, any thoughts?
Yeah, so let's say for vector in specific and for those people that you mentioned, there's a lot of research involved there as well, right? So there is a little difference between the research side and the industry side as well, right? So with the deployment comes into play when we are working more with the industry side, which has more pressure on production, unlike real client, real time like predictions and inferences, right? There is a lot of I think vector sits right in the middle of that. Like it has a lot of relationships with the industry side and a lot of relationships with the research side as well. So let's say when you talk about Jeff Hinton and Marcelo, they come from the research side and move to the industry side of things, and I think vector is the one in the middle trying to make this bridge work, right?
One more question. Is there a demo or toy deployment to teach using Terraform to do inference of small, for example, small LM2 models?
I think you can use this reference implementation to do that. Like for Terraform, the way that this reference implementation is set up, you don't need to do a lot. You don't even need to know a lot of Terraform to bring this up. So if you just follow the guide, you should be able to bring it up, even if you don't know Terraform at all. You can install in your local machine and just run the reference implementation as it's explained on the guide. You should be able to put something up. Let's say for models like small M2, let's say if this model is available in Hugging Face, for example, or I would say run the reference implementation with the BERT model that I showed, and that is gonna you have a end-to-end pipeline working with a model that is gonna it's gonna be similar to this one that you're talking about for like a small model like that, right? You can even choose the machine that you're gonna push the model in. If that machine is gonna be a GPU, or if the model is small enough to run in a CPU machine, you can change that as you need it as well. On the reference implementation, you're gonna have some Terraform scripts and some Python scripts. And there you can change the types of the machines depending on the ones that you need. I think for the BERT model, there is a small GPU that I use there. If your model uses a even smaller machine, you can go there and choose the kind of GPU or even CPU that you need to run that model on. And then modify the reference implementation as needed to push the small M2 model that you were referring to instead of the BERT model that exists there. So just to finalize, I would say run the reference implementation pipeline, like pick one online, offline with the BERT model, and that's gonna at the end have a working pipeline for you end to end. And after that, you replace the model with the model that you need, and after that, you just need to make some other modifications that suits you.
Yeah, thanks a lot for the wonderful talk and wonderful answers. Also, thanks the audience for the great questions. Yeah, thank you very much.
Thanks, everyone.